Hi, everybody. I just wanted to get a little bit more space here for the next couple of examples. So let's jump back in. We left off with B. Now here we have -1 plus root -5 squared. Remember, before you really do a lot of calculations, you need to put it into that I form anyway. So it's probably easiest to start with it in the I form now. So what I'm going to do is just rewrite this. So root -5 is the same thing as root -1 times root 5. And this is your I right here. So this becomes I root 5 all squared. Now remember that when you're squaring something, you are basically writing it out twice and doing that multiplication. So -1 times -1 is +1. -1 times positive I root 5 is just negative I root 5. On the inside here, I'm going to have the same thing, negative I root 5. And then at the end here, let's see, I have I times I is I squared. And then I also have root 5 times root 5. I'm going to combine my like terms here. So I have -2i root 5. Now remember, when you're adding and subtracting with roots, it's kind of like variables. That root 5 stays. And then you're combining the minus I and the minus I. So that's how I get the -2, right? Because there's a 1 there and a 1 there. Here, I squared is -1. And if I think about this piece here, root 5 times root 5 is the same thing as root 5 squared, right? Because there's two of them. So what happens is that root and that square are going to cancel each other out. And I'm left with 1 minus 2i root 5 minus just 5. 1 times 5 is 5. Here I have like terms, or I combine the real part, so I have -4 minus 2i root 5. And this is as good as it's going to get. I have my real part first and my imaginary part second. So this is in standard form. I think you'll notice maybe, at least with the complex numbers, the biggest part is knowing your basic algebra. So remembering things like if you have the same root multiplied by itself, that root will cancel out. Root 5 times root 5 is just 5, for instance. Or knowing that, when you're adding or subtracting roots, we add or subtract the outside numbers and leave the root alone, like we would with like terms or variables. So let's do C here. And again, I'm going to just jump in and fix this root -50. So that is the square root of -1 times root 50. So you have I root 50. But that root 50 can be broken down. So root 50 is the same thing as root 25 times root 2, right? Because 25 times 2 is 50. And this is a perfect square. So remember, you do want to see if you can simplify. If a root has a perfect square in it, then you want to break that down. So this part actually becomes I times 5 root 2, or just 5i root 2. So as I get started here for problem C, I'm going to rewrite it. -25 plus 5i root 2 over 15. Now, the 15 is already a real number. So this is not the same as regular complex division because I don't have any i's in the denominator. So I don't have to use the complex conjugate here. I only do that if I have i's in the denominator. I don't have the imaginary unit, so all I'm going to do is split this problem. I'm going to put that 15 with the -25. And then I'm going to put that 15 with the 5i root 2. Now, when you simplify it with fractions here, you don't actually simplify the 15 inside the root. So you're looking at this fraction and you're looking at this fraction. Now, of course, this one can be divided by 5 in both parts, and so can this one. So I have -5 over 3 plus, let's see, 1i over 3 root 2. Or you can write that as -5/3 plus I over 3 root 2. Another way you can write it, if you want to, I don't know, make it look a little bit nicer. is you could write the I and then write the root 2 over the 3 that way. So if this looks a little bit weird to you, then you can write the I out front. And then just remember that root 2 is in the numerator and 3 is in the denominator. So you could write your fraction that way too. All right, so that would be your final answer there in standard form. Now, the last thing I want to talk about are the powers of I. So remember that I is just the square root of -1. Okay. And we're going to use that idea. So I to the first power is obviously just I. Okay. I to the second power we're saying is -1. Well, the reason we know that is because when we have I squared, we're taking this and we're squaring it as well. So you get that the root and the square cancel, which is how you get that I squared is just -1. When you get to I cubed, well, I cubed is the same as I squared times I, right? I have 3 of them, so I could break it down into 2 and 1. We're still being multiplied here. And we just saw that I squared is -1. So this becomes -1 times I, which is -I. So that's how we get that value here. And then for I to the fourth, well, I to the fourth is the same thing as I squared times I squared, right? Because I have 2 here and 2 here, that gives me 4 altogether. Well, I squared is -1 and I squared is -1, and -1 times -1 is +1. So when they use these powers, we're really just using the base of what we know. So what do we know is pretty much this, like the only thing we kind of know that works out is that I squared. So notice that everything I'm doing comes back to that I squared idea in these cases. So this one I can also actually write as I squared, right? Because I have 2 of them, which is -1 squared, or also 1. So that's another way that I could write that. But they all come down to really using I squared to simplify these powers. And I want you to really think of these like little puzzles and think about how can I get an I squared in there? And that's usually the easiest way to do it, because I squared is the only one we really know. I squared is -1. All the others, or I guess we know I to the fourth now is +1, but our base idea is this one right here. So the way I like to do it is I try to get everything into kind of squares, and then I go from there. So here we have I to the 27. Now I don't really want to have to go, write 27 I's out or anything like that. I want to try to simplify it. And I want to remember that my I squared is my base idea. So if I think about the number 27, well, that's an odd number. So 2 doesn't go into it evenly. But 26 would, right? So what I could do first is think of this as, well, I to the 26 times I. Okay. So I'm looking for an even power because then I can use the idea of a 2 here. Well, 26 divided by 2 is 13. So this is the same thing as I squared to the 13th power times I. And the reason that works is because 2 times 13 is 26. So this is one of those exponent rules that we use, where if you have a double exponent, you multiply. So this becomes -1 to the 13th power times I. And what do you guys think? If I have -1 multiplied 13 times, it's going to end up being positive or negative. Well, it'll be negative, right? Because all my negatives cancel in pairs of 2. So if I have 13 of them, I'm going to have a negative left over. So this is -1 times I, or -I. So I to the 27 is going to be -I. So when you're doing these, and again, you can look at your book, they have used a slightly different strategy. But for me, I look at it like, okay, everything comes down to that square. So if I can break things into I squared, then I can get started because I know I squared is -1. So this one here, right? This is already even. And 58 divided by 2 is going to be 29. So this is the same thing as I squared to the 29th power, because 2 times 29 is 58. This becomes -1 to the 29th power. And then think about this. If you have -1 multiplied 29 times, it's either going to be positive or -1. And because I have that extra odd value there, I'm going to have an extra negative. So I'm going to have this -1 as my final answer. So again, think about your squares. So your goal here is to get it to an even exponent. If it's already even, then you're just basically dividing it with 2 and moving from there. If it's not even, though, what you're going to do is pull out one I and then write the even component, right? So if I had something like I to the 101, what I'm going to do is I'm going to pull out one I and then write the exponent with one less, 100, because now it's even. So for that even piece here, I can now write it with a square, and to get 100, I would do 2 times 50. Well, I squared is -1. -1 to the 50th power would be a +1, right? Because all my negatives would cancel. So this is 1 times I, which is just I. What you're going to notice as you go through these powers of I is that you're only going to end up with 4 answers. Either you're going to have I, -1, -I, or +1 for your answer. So here we saw a -I, we saw a -1, and we saw a +I. So you can only have one of 4 answers there. They're all going to boil down to one of these 4, because then basically after that, they just keep repeating over and over again. So give these a try. Think of them like puzzles. Students always struggle with these, but think of them like puzzles. And the trick there is to get that exponent to be even, because then you can make it into an I squared. And that's how you can simplify.